Hey, good people, this is Arthur Morris. Welcome back. In this video, we are going to look at the definition of logarithmic functions. Logarithmic functions. Right, so we have for all of x that are greater than 0 and b that are greater than 0, where b does not equal 1. If we have y equal log base b of x, that is equivalent to b base b to the power of y equals x. The function f of x equals log base b of x is the logarithmic function with base b. So we're going to look at logarithmic functions and writing these back and forth from logarithmic to exponential and exponential to logarithmic functions, the equivalent functions. So to change from logarithmic form to the more familiar exponential form, we use the pattern as shown. If we have y equals log base b of x, that means b raised to the power of y equals x. Now the base remains the base, so the base of the logarithmic function is the base of the exponential function. And then the y and the x swap sides. The y becomes the exponent and it's equal to x. Okay, so let's look at a few examples. All right, so if I want to write these equations in the equivalent exponential form, so a here we have, and I'm going to rewrite this, we have log base 2 of x equals 4. And we want to write this in exponential form. So the base of 2 will remain the base of the uh, exponential form. And then the x and the 4 will swap sides. The 4 will become the exponent, and the x will just go to the other side of the equation. So 2 to the 4th equals x. It's the same thing as log base 2 of x equals 4. Okay, part B, again we have x equals log base 3 of 9. I'm just switching sides. That really doesn't matter. I just like my log to be on the left hand side when I'm transforming these to exponential form. So the base, log base 3, the base will remain the base. So 3, and then the 9 and the x will switch sides. So x equals, or log base 3 of 9 equals x is the same thing as 3 to the power of x equals 9 in exponential form. Okay, now let's go the reverse direction. Let's start off with the exponential form and write the equivalent logarithmic form. So b raised to the power of 4 equals 16. The base will remain the base, so the base of the exponent will become the base of the logarithm. And then the 4 and the 16 will swap sides. So we're not simplifying anything. We are just writing these in the equivalent logarithmic form. Okay, so here we have 5 squared equals x. Okay, so my base is 5, so that it will remain the base. And then the x and the 2 will swap sides. All right, let's look at another example here. So here we have the cube root of 27 equals 3. The cube root of 27 equals 3, and we want to write this in its equivalent logarithmic form. So the first thing I'm going to do is to simplify the cube root of 27, which is 3 to the first power. Now I'm going to write this in the logarithmic form. So I have base 3 raised to the power of 1 equals 3. So the base of the exponent remains the base of the logarithm, and then the 1 and the 3 swap sides. And this is one of the properties that we have of logarithms. If the base of the logarithm is the same thing as what we're taking the logarithm of, then that is equal to 1. So log base 3 of 3 equals 1. Now let's look at evaluating some of these logarithmic expressions. Now we have expressions, and I like to change my expressions into equations and then rewrite them in exponential form and evaluate. So the first one we have here is log base 3 of 81. So I'm going to say log base 3 of 81 is equal to x. Now I'm going to rewrite that in exponential form. So base 3, the x and the 81 swap sides. So 3 to the power of x equals 81. Now one way to simplify these is to try to write the two sides with the same base. So if I think about 81 and try to write it with the base of 3, I know that 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81. So now I can rewrite 81 with a base of 3 by saying 3 to the fourth power. So 3 to the power of x equals 3 to the fourth power. Now the reason I do that is because if they have the same base, then the exponents have to be equal as well. So I can simplify this now by saying x equals 4 by setting the exponents equal to each other. So log base 3 of 81 is equal to 4. Okay, so let's try another one. First of all, let's create an equation. Then we will use that equation, rewrite that equation in exponential form. So base 36 raised to the power of x equals 6. Now we want both sides to have the same base if possible. So if I think about 36 and try to write it with a base of 6, then I know that 6 to the first power is equal to 6. 6 to the second power is equal to 36. So I can rewrite 36 as 6 to the second power. Now keep in mind we already have an x in the exponent place there. So that will become 6 to the power of 2x equals 6 to the power of 1. That's understood to be 1 there. So again, if the bases are equal, then the exponents are equal as well. So now I can set the exponents equal to each other and solve the equation to find the answer. So now 2x equals 1, therefore x equals 1/2. And what that tells me is that log base 36 of 6 equals 1/2. Okay, and for the final one here, log base 5 of 1, again, let's create an equation. Let's rewrite the equation in exponential notation or exponential form. So base 5 raised to the power of x equals 1. Now if we can rewrite these sides to have the same base, then it makes it easier to solve. So I could rewrite 1 with a base of 5 because I know that anything raised to the power of 0 equals 1. So I know that 1 is equal to 5 raised to the power of 0. Therefore, set the exponents equal to each other, x equals 0, which tells me that log base 5 of 1 equals 0. And that's another one of our logarithmic properties, that anytime we have the log of base whatever of 1, then that will equal 0. Okay, let's evaluate a couple of more of these expressions. So here we want to evaluate log base 6 of the square root of 6. So we will do the same thing. We want to create an equation out of it, and then rewrite it in the exponential form. Now I know that I can rewrite the square root of 6 in exponential form as well, because the square root could be written as the 1/2 power. So the square root could be written as 6 to the power of 1/2. Now that I have the same base, that means the exponents are equal to each other. X equals 1/2, or log base 6 of the square root of 6 equals 1/2. All right, let's look at one more. So here I have log base 2 of 2 to the power of 8. So again, create an equation, write it in exponential form, so the base of 2 remains the base, the x and the 2 to the 8 swap sides, and then you clearly see that we already have the same base, therefore the exponents must be equal to each other. So log base 2 of 2 to the power of 8 is equal to 8. And there you will see another one of those logarithmic properties. Alrighty, good people, I hope you found this video to be helpful, and I'll see you on the next one. Thank you.